Lesson 6 for dividing fractions, and in this lesson you'll learn to divide fractions using multiplicative inverses. Uh, why it's important? Because knowing how to divide fractions will help you know how much food to order for a group. Okay, let's take a look at this activity. One way to think of 6 divided by 6 divided by 2, is to say how many 2's there are in 6. Okay, so think of this way of thinking, okay, because we are going to use an area model to help you divide fractions. So again, when you say 6 divided by 2, we are basically saying how many 2's there are in 6. And we know that there are 3 2's in 6. That's the reason why 6 divided by 2 is equal to 3. Okay? Put that on top of your mind, because this is how we are going to divide fractions using models. The drawing at the right shows a model of 3/4 divided by 1/2. Okay, why is it 3/4 divided by 1/2? So when this is shade is blue, okay, that's 3/4, and we want to divide it by 1/2. Okay. So before we do that, to find the quotient, first draw a rectangle to represent 1 unit. That's our rectangle. Okay, divide it into 4 equal parts. Okay, and then shade 3 to represent 3/4, and that's what we have there. Then determine how many halves are contained in the shaded area. You know that this is 1/2 of the rectangle right here, and this is 1/2 of the rectangle. Okay. So if this is 1/2 of the rectangle, this particular area right here represents 1/2 of 1/2. Okay. Now, after that, determine how many halves are contained in the shaded area. And you know that if this is 1/2, there are 1, 2, 3 halves contained. Okay. So therefore, when you divide 3/4 divided by 1/2, it'll be 3 halves, or 1 and 1/2. Okay, so that's how you use models for that. Let's do this particular model of ours. Let's model 2 and 3/4 divided by 4/9. Let's follow the step-by-step direction. Draw 3 rectangles and divide it into thirds. I already did that. You have 3 rectangles divided into thirds. Okay, and then shade 2 and 2/3 of the rectangle. So we're going to shade 2 and 2/3 of it. Let's use a crayon for this one. Okay, red crayon. So if we're going to shade 2 and 2/3, this is how much we are going to shade. 1, 2, and 2/3 right here. Okay. So that is 2 and 2/3. Okay. Add additional marks to show ninths in each rectangle, because we are dividing it by 4/9. So what we do is we get our little line there and start dividing it into ninths. Make that straight. There you go. There you go. So you have 4, 1, 2, 3. No, that's not 9. Okay, need to add one more there. There, add one more there. There, now they're 9. One more. Let's confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Okay, let's do the same thing for this rectangle, dividing them into ninths. Okay. And for this last rectangle, bring that down. Oops, not that one. This one. Alrighty. Well, give me one more line in there. Now our rectangle is into ninths, so we want to divide it in 4/9. Okay. So what we want to do is mark as many groups of 4 over 9 as you can. So let's start marking those 4 over 9 shades. So 1, 2, 3, 4, that is 1. Okay. 1, 2, 3, 4, there you go. 1, 2, 3, 4, that is the second one. 4 ninths. So 4 ninths. 4 ninths. Okay, 1, 2, 3, 4, just making sure all the way there. Okay, 1, 2, 3, 4. There's another 4 ninths. Okay, 1, 2, 3, 4. It's another 4 ninths right there. Okay, 1, 2, 3, 4. Another 4 ninths right there. Okay, 1, 2, 3, 4. Another 4 ninths. Okay, so if you notice, how many groups of 4 ninths did you find? 1, 2, 3, 4, 5, 6. We found 6 groups of 4 ninths. Okay, what is the quotient of 2 and 2/3 divided by 4 ninths? And the answer would still be 6. And that's how you use models to divide, okay, mixed numbers and fractions, or fractions and mixed numbers. Okay, let's take a look at this one. Let's learn another concept. You can use the same skills to divide fractions as you use divide integers. For example, dividing 40 by 2 is the same as multiplying 40 by 1/2. In each case, okay, in each case, the solution is 20. In other words, dividing by 2 is the same as multiplying by 1/2. Okay, again, when you divide by 2, okay, it is the same as multiplying by 1/2. Okay, so if you notice, 2 times 1/2 equals 1. Two numbers whose product is 1 are multiplicative inverses or reciprocals of each other. So 2 and 1/2 are multiplicative inverses. In the same way, negative 3/2 and negative 2/3 are multiplicative inverses because negative 3/2 times negative 2/3 is equal to 1, which brings us to the definition, inverse property of multiplication. So the inverse property of multiplication simply states the product of a number and its multiplicative inverse is 1. In symbols, for every non-zero number a over b, again, where b is not equal to 0, because it will not be defined if it's equal to 0, there is exactly one number b over a, such that a over b times b over a is equal to 1. Okay, take note that the product should be 1, not negative 1. So it should be a positive 1, which brings us to the think about it. Are 3/4 and negative 4 over 3 multiplicative inverses? Remember that the product should be 1, and if I multiply negative 3/4 and negative 4 over 3, okay, it would not be 1, so the answer would be no, because 3/4 times negative 4 over 3 is equal to negative 1. So they are not reciprocals. Again, the product should always end up with 1. Okay, so remember that dividing by 2 was the same as multiplying by 1/2. It's multiplicative inverse. This is true for any rational number. So we go to our division of fractions. Okay, so when you're in the division of fractions, in words, to divide a fraction, multiply by its multiplicative inverse. For fractions in symbols, for fractions a over b and c over d, where b, c, and d, okay, are not equal to 0. Again, you know why. So where b, c, d are not equal to 0, a over b divided by c over d is equal to a over b times d over c. So if you notice, okay, your division becomes multiplication, and you are getting the reciprocal of your divisor. So your divisor is c over d. You get the reciprocal of your divisor, okay, and then multiply it with your dividend, okay. And also, if you notice, your dividend did not change. So your dividend remained the same. It's only the divisor that changed, okay. Let's take a look at example number 1 and see how this works. Go right away to a word problem. Robert G. Fernandez, a vice president at a financial corporation in Austin, Texas, wrote an article on money management in a magazine. The magazine is printed on a 8.5 by 11-inch pages, okay, the regular size of paper, and the articles are printed in 3 columns. If the margins are 3/8 of an inch on the left and right side of the page, and there is a 1/4 inch of space between the columns, how wide should the columns on this computer be set? Okay. Now you know that the total width of the page, okay, and the width of the margins and the amount of space between each column. There are 3 equal columns. You need to know how wide to make each column. Okay. So that is what we know, and that's what we need to find out. You need to know how wide to make each column. I don't know with you, but I am a visual learner. So that means you need to make a diagram and mark the widths, okay? Subtract the known widths from the total width, then divide the remaining width by 3. And this is how your diagram should look like. So this is your 8.5 paper right there. This is 8.5 inches. Okay, the very top. Okay, and there is a 1/4 margin between columns, and there is a 3/8 margin, okay, on the left and right side of the paper. We want to know, okay, the width of each column. So what do we do? Okay, knowing what needs to be done, this is what we need to do. We get 8.1/2, then we subtract the 2 margins, 3/8 and 3/8, and then we subtract again the 2 1/4 margins in between those columns. We end up with a sum of 7 1/4. Okay, 7 1/4 obviously will be, when you look at all the LCDs of all those numbers, that was from the previous lessons. Okay, so we get our 7 1/4 and we divide it by 3. Why 3? Because there are 3 columns. Okay, and then we apply the rule of division with fractions. So 7 1/4 divided by 3, let's convert this into an improper fraction, which is 29/4, and we get the reciprocal, and we simply put 3 first, okay, 3/1. And then we use the division of fractions rule, 29/4 multiplied by the reciprocal of 3, which is 1/3, okay, and then, well, let's let this appear, rename 7 1/4 as 29/4 and 3 as 3/1, and then we get the reciprocal or the multiplicative inverse of 3, which is 1/3, okay, and we multiply straight because we cannot see, there is no GCF between 29 and 3 and 4 and 1 except for the number 1. So multiply it straight, multiply the numerators and denominators straight, you end up with 29/12, and make 29/12 as a mixed number. That would be 2 and 5/12. So each column should be 2 and 5/12 inches wide. Okay, so to be able to check our answer, add the widths of all the margins in the 3 columns. The sum should be the width of the paper, which is 8 1/2. And if we do that, okay, add all of them up, okay, with the corresponding width of each column, we end up with 8 1/2, and it checks out. Okay, let's take a look at example number 2. Example number 2, you can use division skills that you developed with integers and fractions to divide negative fractions. So we have solve P equals -3 3/5 divided by 6/7. Okay, so first we copy the problem, -3 3/5 divided by 6/7. We again begin with estimating. That's a -4 divided by 1, which will give us an answer close to -4. So the exact answer should be close to -4 to make sure our answer is reasonable or not. First things first, we convert -3 3/5 into an improper fraction. Okay, and then after converting it into an improper fraction, we now get the reciprocal of 6/7 and multiply it by -18/5, and the reciprocal would be -18/5 times 7/6, okay, because the multiplicative inverse of 6/7 is 7/6, And since we see, okay, we see that there is a GCF between 18 and 6, and that is 3. Oh, sorry, that is 6. 6 divided by 6 would be 1. 18 divided by 6 would be 3. So we multiply 3 times 7, which is 21. 5 times 1, which is 5. So we will have 5, okay, 5 over, sorry, negative 21 over 5, okay, and as a mixed number, that will be negative 4 and 1/5, okay? And we compare our answer to the estimate, very close to each other, okay, our answer is reasonable. And let's take a look at this particular skill, connecting it to algebra. Evaluating algebraic expressions involving division of fraction uses the same procedures as evaluating algebraic expressions with integers. What does that mean? If we're asked to evaluate a squared divided by x, if a is equal to 1/3 and x equals to 1 1/4, again, we go back to the word evaluate. It means find the value of, and 2 steps to find the value of, and that is to substitute and simplify. So in a squared divided by x, we substitute the value for a and substitute the value for x. So we have now 1/3 squared divided by 1 1/4, replacing 1/3 with x, replacing a with 1/3 and x with 1 4/5. Okay? And then we do our exponents first. So this is 1/3 times 1/3 divided 1 1/4, evaluating powers first. And then before we start with our division with fractions rule, okay, we convert 1 4/5 into an improper fraction. So that is now 1 and, in this case, we multiplied 1 1/3, or we evaluated the powers, okay, to become 1 1/9. And then this is now the step, okay, where we get the improper fraction of 1 4/5, okay, which is 9 over 5. Okay, be very careful here. Okay, you cannot cross cancel the 9 and the 9. Okay, so the only time you can cross cancel if that operation is multiplication. If it's division, this cannot happen. Okay, so what do? We multiply by its reciprocal. 1/9 times 5 over 9. Okay, we end up with, okay, 5 over 9 as the reciprocal of 9 over 5. 5 over 81. Okay, so the product is 5 over 81. Okay, the secret word for this lesson is together. So write that as well. Secret word is together. Okay, and that is the end of our lesson. Thank you for watching.